use valence bond theory to explain the bonding in fluorine, hydrogen fluoride, and chlorine bromide in those three molecules. First, let's work on fluorine F2 molecule. So as we can see, fluorine molecule F2 is composed of two fluorine atoms, okay, before their orbitals, atomic orbitals overlap, forming the molecule. You see that's one of the fluorine atom, okay, and we concentrate on the 2p orbital because that's where its a valence electron occupies, all right? And then that's the other fluorine atom. When those two atoms approach toward each other, then eventually fluorine molecule F2 will be formed. Okay, after they get close enough, you see the 2p orbitals from each of the fluorine atoms, they overlap. Okay, so then there is a pair of electrons shared by both fluorine atoms. Now they form a bond, so which is of course a sigma bond. Fluorine. So this bond is a result of overlapping of the two fluorine atomic orbitals, two p orbitals, okay? But if you draw the correct Lewis structure, of course, you still have lone pairs, okay? Therefore, the bond, the sigma bond in F2 molecule is contributed by the 2p orbitals, okay? So 2p orbitals from each of the fluorine atom. Now let's take a look hydrogen fluoride molecule. Okay, so one hydrogen atom, it is one s orbital, approach to the 2p orbital of a fluorine atom. Okay, so when those two atoms, hydrogen and fluorine atoms, approach, you see the sp overlapping is formed. So now you see this right here in this region, that's actually the HF bond. If I try to demonstrate that, that will be hydrogen and then fluorine. And again, I will complete the Lewis structure. So therefore, the hydrogen fluoride molecule is contributed actually by hydrogen's one s orbital and one of the 2p orbitals from fluorine. Now the third molecule, chlorine bromide. So the valence electron from chlorine is actually, that occupies actually the 3p orbital. And the bromine's valence electron, that one of the valence electrons used to form this bond, actually that's from 4p, all right? Which means bromine, of course, is larger than chlorine. So because chlorine is in the third period and bromine is in the fourth period. Okay, when those two approach to form the ClBr molecule, the 3p orbital from chlorine overlap with the 4p p orbital from bromine. You see, then here it forms a sigma bond, Cl, Br. And again, of course, if we complete the Lewis structure, it would look like this. Okay, so easily we can see now this bonding ClBr, that bond is formed using 3p Cl orbital and 4p Br. All right, so therefore that's a 3p from chlorine and then 4p so from bromine. That's it for this question.